Okay, picture this. Right now, there are trillion-dollar AI models out there that are essentially legally trapped. We've got these absolutely incredible frontier-level AI systems that can write complex code, negotiate huge supply contracts, handle sensitive medical intake, but a massive amount of their potential value is just completely bottled up. Why? Well, because right now they are legally and financially uninsurable. So in today's explainer, we're going to crack this mystery. We'll explore exactly why these systems are totally stalled out and how a really fascinating deep tech hardware fix is finally stepping in to unlock them. Let's dive right in. So to set the stage here, this is the big, unavoidable question we have to ask. Why are autonomous AI pilots stalling globally? Because across the entire industry, enterprise AI projects are just hitting a massive brick wall. You know, they work beautifully in the demo sandbox, but they stall the second they hit that pilot to production line. And here's the thing, the blocker isn't capability. These models are incredibly smart. The blocker is accountability. Enterprises build an agent to do a specific job, but they can't actually put it in front of a real, paying customer because, well, no one can absorb the liability if that agent drifts off its assigned task and does something disastrous. And the sheer depth of this problem really comes down to one single number, 0%. Right now, across all major frontier AI vendors, the substrate attestation coverage is exactly 0. What does that actually mean for us? It means the percentage of AI decisions that come with a hardware-grounded, auditable proof of what the AI was actually supposed to do is 0. Not low, literally 0. Because of this, the enterprises trying to deploy these models are walking around carrying completely, totally uninsurable risk.
Which brings us to Section 1, the naked deployer problem.
This trap of the naked deployer is incredibly pressing right now. See, base AI models explicitly disclaim all responsibility. They're just selling a general-purpose engine. So if something goes wrong, the liability bag falls entirely on the deployer, the enterprise that built the specific agent. And the timeline we are looking at here is incredibly tight. In 2025, those pilots are already stalling out. But it gets so much worse. By early 2026, standard insurance policies are going to start actively carving out AI liability. I mean, actuaries simply cannot price a risk they can't measure, right? And then the hammer drops, August 2nd, 2026. That is when the EU AI Act Article 14 enforcement officially begins, and that mandates strict human oversight that standard software simply cannot satisfy. So by that date, running uninsurable AI isn't just risky, it becomes a massive, dated legal liability.
So why can't we just fix it with software? That brings us to Section 2, why guardrails fall short. There is a really sharp contrast here between what feels safe and what is actually insurable. Right now, the industry relies heavily on probabilistic software guardrails, intent classifiers, block lists, you know the drill. And these give you a subjective confidence score. Basically, they make a buyer feel warm and fuzzy. They feel safe. But the very first time a real financial loss lands on the desk of a claims adjuster, a probabilistic confidence score is completely useless as evidence. An underwriter literally cannot rate a feeling. To be truly insurable, an actuary needs a hardware-grounded floor, mathematical proofs, and verifiable receipts, no exceptions. And the actual reason why software guardrails are fundamentally useless in a legal claim comes down to a deep mathematical paradox. It's known as Rice's theorem, dating all the way back to 1953. The absolutely crucial point here is that software monitoring software shares the exact same failure domain. Think about it. If a massive zero-day exploit or a severe semantic drift, which is where the AI just gradually misinterprets its own instructions, if that compromises your AI model, the software guardrail that's supposed to be monitoring it can be compromised by the exact same failure. You just cannot use software to reliably audit software, because they fail together. They go down on the same ship.
So how do we solve this? Let's look at Section 3, the hardware-grounded floor.
To beat this paradox, we literally have to move the audit out of the software entirely and push it all the way down onto the silicon itself. And this is where a deep tech firm called Theorem enters the picture. They've produced what is called an Attested Insurability Receipt, or AIR. The best way to think about this is like Progressive Insurance's OBD2 dongle, you know, the one you plug right into your car. That dongle doesn't run the engine, right? It just sits there, logging your driving behavior to prove you're actually staying in your lane. The AIR daemon is exactly like that. It's a lightweight observer running alongside the AI. It verifies at actual hardware speed that what the agent was told to do perfectly matches what it physically did.
I love how the core promise of this technology is summarized. Quote, "We do not make your agent smarter. We make your agent insurable." That's the whole shebang right there. They don't touch the large language model's brain at all. They aren't trying to magically make a better, smarter AI. They are simply making its actions financially safe to deploy in the real world. They shrink the risk down to a mathematically modelable residual, something an actuary can actually put a price on.
Now, this incredible technology ships in two specific shapes that work together seamlessly. First up, you have the Cloud Bridge. This is the hosted SaaS network, the dashboard that actually issues the insurability receipt that your underwriter is going to accept. It functions kind of on a Visa-shaped envelope, basically acting as the network that lets trusted counterparties safely transact. Second, you have the local PMU, or Performance Monitoring Unit. This is the precision tool. It's an on-silicon binary that provides the closest to metal verification floor you can get. It operates on an ARM-shaped envelope, sitting right there on the deployer's own silicon to monitor cache miss patterns at mind-boggling picosecond speed.
Okay, let's see how this actually rolls out in Section 4, the insurability receipt.
Now you might be wondering, okay, if I install this thing, is it going to just randomly kill my revenue-generating AI agent on day one? The answer is a definitive no. It follows a really clever step-by-step user journey. Step 1 is shadow mode, and this is mandatory. The daemon runs observe only. It emits receipts, it flags drift, but it never, ever kills the process. You absolutely do not break uptime. Step 2 is the tune window. Here, the deployer watches the real false positive rate against live traffic and dials in the sensitivity. And finally, Step 3 is enforcement mode. Once that baseline is rock solid, the live continuous attestation begins. Only then does the gate actually fire and halt a process, and crucially, it does this before a liability-incurring action actually takes place.
And this brings us to what they call the seatbelt model. It's brilliant. Stepping outside the defined boundaries doesn't necessarily kill the system. If an agent tries to execute an action outside its defined confidence map, it's actually allowed to do it. But that specific action is uninsured, unbrokered, and it is recorded permanently on the ledger. Basically, you chose to drive without a seatbelt. A hard interlock, where the system entirely halts the AI dead in its tracks, is the rare exception. It's reserved only for incredibly dangerous actions. Enforcement here is all about membership economics, not brute force coercion.
Which leads us to the big picture in Section 5, a new asset class.
To really grasp the macro scale of this, the source material compares this hardware substrate audit to an invention all the way back from the year 1494. A guy named Pacioli codified double-entry bookkeeping. Before him, businesses just used a single ledger. The auditor and the audited were the exact same thing. Pacioli's double-entry system didn't invent new businesses, but what it did do was make trust mechanical. It made fraud structurally detectable. That one single invention unlocked modern banking, joint stock companies, and basically the entire architecture of the modern enterprise.
And by moving the AI audit down to the hardware substrate, we finally have computing's missing second entry. We literally have a ledger kept by something the software cannot influence. And just like in 1494, this changes absolutely everything. It takes an uninsurable, massive legal hazard and converts it into a priceable asset. It creates a zero-latency economy of confidence where trusted nodes can interact frictionlessly because their reliability is mathematically proven, and most importantly, it unlocks those trapped trillions of dollars of frontier model value we were talking about right at the very beginning of this explainer.
So as we wrap up, I want to leave you with a really provocative thought to ponder. When we finally stop relying on software to monitor software and instead use a hardware-grounded second entry, how entirely will this redefine the trillion-dollar AI economy? Seriously, when trust becomes a mathematical certainty at the silicon level, what brand new forms of global commerce become possible? It's a completely fascinating horizon. Thank you so much for joining me for this explainer. Keep learning, and I will catch you next time.